Welcome to this online video on linear functions. Our outcomes today deal with finding slope and y-intercepts of lines, graphing linear equations, determining equations of lines, and also looking at parallel and perpendicular lines. To begin with, when we're graphing or looking at linear or any other equation, it's important to keep in mind that the linear functions or quadratic functions or any of the other functions that we'll look at have this as sort of their model. We identify some kind of a problem or some kind of relationship, we collect some information about it, graph it, and then we compare that to an established model like a linear or quadratic model. And then use that information to help us try and explain the problem or maybe predict what might happen in the future. And lots of math, although we get caught up with x's and y's sometimes, but lots and lots of math have this as its basis. We're looking at a real world thing and trying mathematically to describe that. Here's some examples of some of those functions or relationships that I was talking about. So we have a linear relationship, we look at that today. Quadratic and cubic, we look at lots of those later on in other videos. And we also, in this course, look at exponential, sinusoidal, and logarithmic functions. Okay, to begin with then, here's an example of a real-world problem or relationship. The question says, what kind of function arises when you compare the amount of money you make versus the amount of tax you pay? So if we're all paying sort of an equal opportunity tax, it would make sense that the more money that we earned, also the more money we had to pay in taxes. So for example, if I earned $1,000, I would pay maybe $200 in taxes. We put some numbers on there and 200 over here. So if I earned $2,000 in wages, then if things were we were paying taxes on how much we earned, if we earned $2,000, we would have to pay $400 in taxes. And as we keep going, we find that earning money and paying taxes appears to be a linear function. And so that's what I was talking about in terms of models. Maybe everybody won't pay exactly the amount, but generally speaking, the more money you earn, the more taxes you're going to pay. So, characteristics of linear functions. There are two characteristics that are of importance to us. And when we graph linear functions or when we write an equation for them, it's these two characteristics that we're most concerned with. And those characteristics are, first, what kind of slope the excuse me, the linear function has, and also where does it cross the y-axis. So I can take this line and I can move it around, and notice that it remains, or it keeps the same slope, but it's crossing this y-axis in different spots. And so every time I move this line, it's defining a different linear function. I could also take the line and I can change its slope. So here I have a greater slope, here I have a lesser slope, and this, the slope also, every time I move that, defines a different linear function. So linear functions have two characteristics that we worry about. The first one is the slope. Often we use the letter m for slope, and also the y-intercept, or where it crosses the y-axis. Typically we use the letter b, not sure why I use b, to represent the y-intercept. And we'll use those two later in the video. So here's some tools that we can use with linear functions when we're describing them. First, m, recall that that is the slope, is equal to the difference in two y values over the difference in two x values. Here's another equation of a linear function. Here's another equation of a linear function. This one I think they call the slope-intercept equation. Oh no, this is the slope-intercept one, and this is the point-slope equation. Also, we'll get some ideas later when we look at horizontal, vertical, parallel, and perpendicular lines. Okay, so those are some tools. We have to keep those in mind as we approach some questions that are coming. First off, this question says determine what the slope is. 2 points are given, and I want to know what the slope is between them. Well, basically the slope is how far a graph rises from one point to another, divided by how far it runs from one point to another. So if I wanted to, with this particular one, I could simply figure out how far it rises. I'm starting there and I have to go up 1, 2, 3, 4. So I'm rising 4. And I'm running 1, 2, 3, 4, 5. So I would say the slope between these two lines is equal to 4 over 5. Now you can do that by counting, or you can use the formula that they've given here, where they say that take the two y values and subtract, take the two x values and subtract. It's important that you do that in the right order. So I typically label my points x1, y1, and this is my point x2, y2. So if I take these numbers and plug them into this formula, this is what I get. 5 is y2, minus 1 is y1, divided by x2 is 3, subtract, x1 is negative 2. Oh, two negatives. I can see some problems there. Be careful with those. Okay, simplifying, 5 take away 1 is 4. 3 take away a negative means I add 3 plus 2 then is 5. And it comes up with the same thing that I achieved just by determining how far I have to rise and how far I have to run from one point to another. So that's one typical question for finding some information about a linear function, specifically slope. Here's another question. This one says find the slope and the y-intercept of the line with this equation. Now if I recall back in my tools, here's a formula right here that told me what the slope and the y-intercept were for a line. Let me check back to my question. Yeah, it's of the same format. If I were to write y equals mx plus b, right below that, this is the formula for a linear function. And if I look at what's in front of x, it's negative 2.3. Therefore, the slope is negative 2.3. Also, the b, what's in the spot of the b, is 4.2. So the y-intercept for that linear function is 4.2. Done. One thing with the slope, which you don't have to do, but typically a slope is written as a fraction, so a numerator over denominator. If I wanted to, I could rewrite that as negative 23 over 10. Those two would be the same. But it doesn't matter. You can write the slope as a decimal or as a fraction. Oh, okay, this one is asking the same question, but my formula is in a different format. Well, I'm okay with that. I know that I need to get here, y equals mx plus b. So if I can rearrange this to look like this, I'll know my slope and my y-intercept. So let's first do that. Let's take the 3x over to the other side. So we use the subtraction property to do that. Subtract 3x on that side. Each side will give you minus 3x on this side, plus the 12 that's there already. Notice I put the x first. I was just thinking because x is first here, I might as well put it first here. Next step is I have to have y, not negative 2y, but y. So I need to use the division property, which says that if I want to get rid of this negative 2, which is being multiplied, I'll divide every term in the equation by negative 2. So I'll come up with negative 3x divided by negative 2, and a positive 12 divided by negative 2. Simplifying a little bit, I'll get rid of the negative signs there, and over here 12 divided by negative 2 is a negative 6. Therefore in this question, or in this equation here, my slope is 3 over 2, means it's going to rise 3 and run 2, and my y-intercept is negative 6. Oh, whoops. Let me just erase that quick, sorry. So my y-intercept is negative 6. Okay. That's slope and y-intercept. Now, here it's asking me to write an equation for the functions with these characteristics. Okay, they tell me what the slope is, they tell me what the y-intercept is. Well, my formula is y equals mx plus b. I could simply plug numbers in there. The slope is -2, and the y-intercept is -3. Done. Here's another one. The slope is 2/3. Oh, this one just gives me a line that passes through 3, 7. It doesn't give me the y-intercept. I wonder if one of these will help me up here. I know my slope, so I don't really need to use this one. I know my slope here, but I don't know what. How about this one? Okay, it gives me a point. Here's a point, x1, y1. And it gives me my slope right there. So if I plug these numbers in for those spots, I should be okay. Let's try it. Y minus y1 equals mx minus x1. Always a good idea to write your formula down first. Now substitute the y value that I was given in the point. My slope, 2/3. X minus, my x point was 3. There. Oh, it doesn't really look right yet because it's supposed to look like this. Well, let's multiply through. Let's do some simplifying. So I'll have y minus 7 is equal to 2/3 x, and 2/3 times 3 gives me -1. So I'm going to have to go over here. Now I'll add 7 to both sides, leaving me with y is equal to 2/3 x. -1 plus 7 will be plus 6. There we go. Now I have my slope, and my y-intercept is 6. The question asks for me to write the equation. This would be the equation. Here's another question at the bottom. This time it gives me 2 points. Don't know my slope yet. But if I look up here, there's a formula that I can find the slope. Once I have the slope, I also have a point. I could use either one of them, and I could follow the same procedure as I did here. Let's follow on though. The last part, almost the last part, is to graph an equation. If I'm given a linear function in this format and I would like to graph it, it's a fairly simple process as long as I can identify what the slope is and what the y-intercept is. To graph, start with your y-intercept, that's -2. Here's my y-axis and here's my x. So -2, I would be right down here. That's my y-intercept. Then it says my slope is 3/4. Rise 3, run 4. So from this point, not from the middle, but from my y-intercept, I rise 3, 1, 2, 3, and I run 4, 1, 2, 3, 4. Now I simply join those 2 points, and there I go. I have graphed this linear equation. Okay, the last concept talked about perpendicular and parallel lines. Just a little bit of definition. Parallel lines are lines which have the same slope. So if they have the same slope, like these two here, here's a blue one and a red one. If the lines have the same slope, they'll never touch. If lines have the same slope, they will never touch. Unless, I guess, it's the same line. Then they would have the same y-intercept. It would be the exact same line. So parallel lines are lines which have the same slope, but different y-intercepts. So perpendicular lines, the ones over here, are ones which have slopes which are the negative reciprocal of each other. Let me explain negative reciprocal, meaning that if the slope of one of the lines, say, was 2/3, the slope of a perpendicular line would be equal to, okay, negative reciprocal. This one's positive, so this one's will be negative, just opposite sign. Reciprocal means flip the fraction over. So 3/2. So the slope of one line might be 2/3, the slope of its perpendicular line would be -3/2. Okay, so today we've talked about linear functions. We've seen that all linear functions can be described with 2 characteristics. That's a slope and a y-intercept. We went through a number of questions where we used the slope and the y-intercept to come up with either equations for a linear function or also to graph them. And we also saw that parallel and perpendicular lines have distinct or have special properties with relation to their slopes and y-intercepts.